Hello, this is Nas from NB Network Lessons. Hope you guys are doing okay. Today, the topic of discussion is circuit analysis, lesson number 3. What I'm going to discuss today is the components involved in DC circuits, not AC circuits, but DC circuits. I'm sure that you've heard, hey, the word resistance, you've heard the word battery, you've heard the word capacitor. In real life, sometimes, your AC, air conditioner, goes out and you call the tech and tech comes and says, oh, you know what, your capacitor is out. So, but what exactly does that capacitor means? What exactly that resistance or resistor means. So we're going to look at it. I have a list of all the components which I'm planning to discuss. We've got battery, resistor, capacitor, inductor, diode, LED, transistor, and then finally transformer. In this lecture, I might not be able to complete all of them. It might take me 2 or 3 lectures, but stick with me and I will try my best to explain you what each component does, what's the functionality of each component. Okay? So first thing is battery. Okay, battery is pretty common thing. I'm sure everybody knows what a battery is. When you go to a store and buy a 9 volt or a 1.5 volt, that's a DC battery. It provides energy, all right, in form of direct current. So its a symbol is like this. You have plus, minus, all right. So this can be also like a power supply also, which is basically providing you energy. Power supply, battery, okay? And if you go to the store and you buy a battery, and you will see something like this. You will have this, lines like this, and lines like this. So remember that the bigger line is always going to be positive, all right? And the one with the smaller line on the bottom right here is negative, okay? And voltage is basically also known as potential energy, potential difference. What it is that it's basically like a push. I've explained in my previous lecture. It's like a push. The more push you have, the higher the voltage, the more current you can flow. So that's what the voltage is. It's a push, all right? So base unit of voltage is V, okay? So let's look at the next one. Next one is very common component used in direct currents, DC circuits, okay? It's called resistor, okay? Just as the name represents, it offers resistance to a current. Now, if you have a DC circuit, it could be a circuit in a toy, it could be a circuit in a computer. There are times when you want to limit the current, okay? You don't want that much current to flow. So what you do is that you introduce resistance, okay, in form of a resistor. So that's what the really work of resistor is, to kind of like slow you down. Hey, you're sending me too much current, okay? If I send too much current, it might burn a component ahead of it. So basically it says, okay, if you're sending me 10 amp, I'm going to offer you resistance because my next component only needs 2 amperes. So that's kind of like what resistance is, and the symbol is like this, okay? And the base unit of resistance or resistor is ohm, okay? And it's represented like this, okay? So let's discuss next. Next is going to be capacitor. What the heck is a capacitor? Capacitors you might have heard, like I said, if you ever had an issue with your air conditioner, or if you ever had an issue with some of your electric toys or anything like that, and you take it to electronic shop and they fix it and say, oh, you have a bad capacitor, we need to replace that. But we need to know what the heck capacitor is. So capacitor is something which stores electric charge or electric field, okay? Electric field. And I'll give you an example also, which might make sense to you. And the sign of capacitor is like this. You have, this is capacitor, and the unit of capacitor is farad, okay? All right. So basically what it does is that it stores the electric charge, and we use that charge as needed. One example is, in the olden days, maybe, I don't know if they still used flash cameras. What you had to do was you had to, when you press the button, you're discharging the electric charge out of the flashlight, and boom, it goes. And then it takes like maybe a minute or 30 seconds to get it charged again. And that's all the capacitors which store energy, which store electric charge. That's the time it takes them to charge, okay? So that's what capacitor is. And capacitors, if you look at it, they're the farad, and it can be microfarad, okay? It can be millifarad and so forth, okay? But basically, the thing to remember is it has two plates, like right here, and these two plates do not touch each other, okay? And what happens is that when we have a current going through, okay, we generate electric field right here on these plates, okay? And then what we do is that we store that electric charge, electric field. So that's what a capacitor is. So basically the charges on these plates create electric field. So it's important to remember charges on these plates, okay, create electric field. And we use it as needed. In computers, in other circuits, you need capacitors, and some of the components might need a charge at a given time, okay? Not all the time. So you program in such a way that when a certain component needs a charge, you basically go ahead and use your capacitors to provide that energy.